All right. So today I'm going to be talking about building predictive models for heart disease using random forest, gradient boosting, AdaBoost, and neural networks on the 2015 BRFSS survey. So, why should you care about heart disease? Well, heart disease is the leading cause of death in the United States, with roughly 1 in 4 Americans dying due to heart disease every year. It's also costing the U.S. about $220 billion a year to cover the costs of this disease, and it impacts individuals all across the country. How do you get heart disease? Well, it ultimately boils down to a combination of lifestyle and genetic factors. These risk factors include an unhealthy diet, physical inactivity, excessive alcohol consumption, smoking, and essentially all this leads to plaque buildup and damage in your arteries, which can lead to a damaged heart. What I'm interested in is the binary classification problem. That is, can we predict whether or not someone will have heart disease or a heart attack based on different features that we can select from the BRFSS survey? So people responding to questions can determine if they will have a heart attack or disease, if they won't. So part one, getting and cleaning the data. I have my data set, that BRFSS 2015. I performed some initial feature selection because there are a lot of features. I did some data cleaning, and then I addressed a class imbalance problem because I had way more having heart disease than not. So the BRFSS has 330 features, 441,456 responses. It's a health survey that's conducted by telephone every year, and it measures these health-related risk factors, and there's a good body of research supporting these machine learning methods on that as well. My response variable was heart disease or heart attack. So if the respondents had ever said they had heart disease or if they'd had a heart attack before, then that I changed that to be 1 for heart disease and 0 for never having heart disease or a heart attack. In terms of the features then I selected from that, because there were 330 originally, I selected 22. These include things like high blood pressure, high cholesterol, a BMI indicator, something about their diet, how many fruits and veggies they're eating, demographic information, and just some general health statistics and metrics. So cleaning, I actually use the codebook that they provide to go in because obviously the values for survey responses can be a little tricky to deal with in some of these machine learning problems. I removed all the missing values, all the refused to answer, and we're not sure or don't knows, modified and renamed the values, and ultimately ended up about 250,000 responses. So from this, I dealt with the class imbalance problem by splitting into 3 groups. The first was the full data set with the class imbalance, and then 50-50 or as equal number, and a 60-40 split as well. And I trained on all those. So the model building, I did random forest, gradient boosting, AdaBoost, and neural networks. And so with all these, I was testing some different parameters within them, as well as doing with feature selection and without, and I present the best of what I found. So for random forests, big table, the main takeaway is that the full data set had about 89% accuracy, 74% AUC, and a 48-second runtime. It took out important features with the feature selection turned on, like their blood pressure and BMI, things like that. For gradient boosting, it was a similar story, a little bit higher accuracy in AUC this time, even on the full data set, and actually no losses when compared to the feature selection. So we really want to do the feature selection. It cuts the runtime by about a third. AdaBoost, same story. Tested some different parameters, but ultimately got high accuracy AUC. The features selected as well were, I'm running out of my capacity to record. Pause this. Okay, sorry about that. The program I'm using has a 5 limit time period to record. So I'm jumping right back in, starting the timer. Now, so talking about neural networks now, Main takeaway again, that full data set got a very high accuracy in AUC, so that was an important finding, and the runtime was also good. I tested a number of different parameter settings and found that Atom Solver and a logistic activation worked well. So to review, I looked at 4 models with feature selection and without feature selection. Our full data set, 50/50 class imbalance solving, and 64/40. Looking at accuracy, AUC, and runtime. For the best of the best models that I got, again, that neural network with feature selection turned on was my best model. It had 91% accuracy, an 84 AUC, and 36-second runtime. There were some drops in accuracy and AUC for the 50/50 and 60/40. But ultimately, both the random forest in the beginning and then that gradient boosting Ada neural network, the feature selection that took place identified risk factors that are already identified in the research, including demographics. Males are more likely, so sex, high blood pressure, high cholesterol, BMI, those all factored in. But ultimately, from this, we want to remember, eat healthy foods, increase your physical activity. Those are important to these models that predicted heart disease fairly accurately. It's especially important if you're over age 65, because age was an important factor in these predictions as well as mental health, which is interesting, also came up in all the models. So today, we looked at building predictive models for heart disease using the BRFSS 2015, random forest, gradient boosting, AdaBoost, and neural networks. That best model I got for the full data set was the neural network with feature selection turned on. I got a 91% accuracy. Thank you.